All right, so we're going to do a continuation of our right triangle trigonometry, but today we're going to talk about word problems and we're going to talk about angles of elevation and angles of depression. So angles of elevation, angle of depression are congruent for any situation. So what is an angle of elevation and angle of depression? It's basically how you look at something. So I have a bird that's in the top of the tree. Now that bird has a horizontal line of sight. And when that bird looks down, he's making an angle of depression to the dog. So we have a line of sight and then down to the dog. That is going to be your angle of depression because it's looking downward. Now, the dog has a horizontal line of sight and he's going to look upward and make an angle of elevation up to the bird. So these two angles are congruent to each other because the bird looking down at the dog is going to make the same angle as the dog looking up at the bird. All right, so another situation. So we're on the top of a cliff. Let's say that you're standing up here and you're going to ask yourself, or you're going to look at your line of sight and you have an angle of, a line of sight, and when you look down, you see that there is a boat. So you made an angle of depression. Now, let's pretend that there's somebody on the boat. So somebody on the boat, they are going to have a line of sight, and then they're going to look up at you, and then that's going to be your angle of elevation. So you have an angle of elevation here that is the same angle as your angle of depression of the person looking down. So you have an angle of elevation, angle of depression, depends on which direction you're looking up. If you're looking down, it's angle of depression. If you're looking up, it's angle of elevation. But they are equivalent in nature and in measurement. So when we look at this first word problem, it says you have an angle of depression of a buoy from the top of the something bay lighthouse. I'm not going to try to pronounce that. 130 feet above the surface of the water. So we have a lighthouse, okay? So I don't know what my lighthouse looks like, but we have a lighthouse, and then we have some water, okay? So I always like to draw a picture, and then I have a buoy in the water, okay? Now, it says that it has an angle of depression. So a lot of students just think, oh, I'm going to make this line, and here's my angle of depression. That does not have a line of sight. That cannot be your angle of depression. So what I have to do is I have to make my line of sight. So let me zoom in a little bit. And then my angle of depression is the angle that goes down to the buoy. So that angle of depression is 6 degrees. Now, in that same sentence though, if this angle is 6 degrees, my angle of elevation is also going to be 6 degrees. So if I have an angle of depression, I would always move your angle of depression and make it an angle of elevation to make it easier to read, because you're basically going to make a right triangle. And if you haven't noticed by now, we're making this right triangle between the lighthouse and the buoy and the water. So the lighthouse, the buoy, and the water is my right angle, my right triangle. All right, so with that being said, it says that the lighthouse is 130 feet above the surface of the water. So we have 130 feet. They want to know, find the X distance from the base of the lighthouse, so the base of the lighthouse here, to the buoy. They want that horizontal distance, so we're going to call that X. All right, so now we have enough information. We need to identify our key pieces. All right, so when I look at this, I can see that I'm looking for my angle of 6. I have an adjacent side. So this side over here is adjacent, and this is opposite. So we're going to use tangent in this problem. So the tangent of 6 degrees equals my opposite 130 over my adjacent x. Now once I set that up, I'm going to cross multiply. So x times the tangent of 6 equals 130, and then I'm going to divide by the tangent of 6. All right, and then I can bring up Desmos. And again, I'm going to make sure that my Desmos calculator is in degree mode, which mine is. So I have 130, and then I have the tangent of 6. So my lighthouse, from the distance from my lighthouse to the buoy, is about 1,236, we'll say 0.9 feet. Okay. All right, so here's another example. So we have a cathedral. So the angle of elevation. So why do I know this is an angle of elevation? Because I have a line of sight, and then my line of sight is looking up to the top of the steeple. Okay, so this is my angle of elevation right here. So we have an angle of elevation to the top of the cathedral from a point that is 300 feet away from the base. So we have the base of the church, and it's 300 feet away from that point. So that's the bottom horizontal distance. Then it says, find the height of the cathedral. So we're looking for the height here. I think they called it H. You can call it X, however you want to do it. So I'm looking from the angle of 60. So across the triangle, I have an opposite, and then I have an adjacent. So again, we're going to use tangent. Tangent, I will say, is used a lot, but do not assume that tangent is used every time. So the tangent of 60 equals x over 300. So we're going to put that over 1. So we have x equals 300 times the tangent of 60. All right, so we're going to plug that right into Desmos. So we have 300 times the tangent of 60. And we get x is approximately 519.6 feet tall for that cathedral. All right, so for the next one, I have a hot air balloon over Park City. It is 760 feet above the ground. The angle of depression from the balloon to an observer is 5.25 degrees. Assuming the ground is relatively flat, how far is the observer from the point on the ground directly below the balloon? All right, so we have our little hot air balloon. You can draw a little picture if you want. You know, whatever, however you want to set that up. Then we have an observer that's on the ground. Okay, so we have our observer right here. Now, it says the hot air balloon is 760 feet above the ground. All right. Then it says there's an angle of depression. So if you're standing here, so let me highlight. If you're on the balloon, you have an line of sight, and that angle of depression is going down. Now, that angle of depression is 5.25 degrees. But like I said, you need to switch that up and put that in your angle of elevation. It'll make it a lot easier to analyze your problem, because we're going to make this right triangle right here. Because remember, angle of elevation, angle of depression are the same measurement. Now, it says assuming that the ground is relatively flat, so it's talking about this distance here. All right, we want to know how far is the observer from a point directly, so here's my point, below it. So we're looking for this distance right here. All right, so given that information, let's look again. So we're going to look from our angle. So it looks like we're going to be using tangent again, because we have an opposite and we have an adjacent. Like I said, you will use it a lot, but that doesn't necessarily mean you use it every time. So we have tangent of 5.25 degrees equals 760 over x. All right, so I'm going to cross multiply. So we have x times the tangent of 5.25 equals 760. And then we're going to divide by the tangent of 5.25 on both sides. And I'm trying to get it all on that page because I'm writing kind of big here. All right, so 760 divided by the tangent of 5.25. And so I got that the horizontal distance x is approximately 8,271.0 feet. All right. So let's continue. I have another example here. So we have the height of the tallest chimney. And it says the world's tallest smokehouse is at International Nickel Company in Sudbury, Ontario. Casts a shadow that represents 1,500 feet long. When the sun has an angle of elevation, that's shown on the picture, and it's 38 degrees, how tall is that house? So this right here is actually the sun looking down. So this is actually the angle of depression, but we should know that the angle of depression, the angle of elevation are the same. So they want to know how tall is this smokestack. So opposite of 38, we have x, then we have adjacent. So again, we're going to be using tangent. So the tangent of 38 equals x over 1,580. Cross multiply. So x equals 1,580 times the tangent of 38. Plug that right on in. And I got that smokestack is going to be approximately 1,234.4 feet. Now, this next one is a little bit different. We can clearly see that there's like two triangles happening here. But it says the angle of elevation from an observer to the bottom edge of the Delaware River Bridge observation deck is located 200 feet from the observer, and it is 30 degrees. The angle of elevation from the observer to the top of the observation deck is 40 degrees. What is the height of the observation deck? So basically, I have this observer. So the observer is looking to the deck itself, and that's 30 degrees. And then he looks to the top of the deck, and that's 40 degrees. So really what we need to do is we kind of need to make two separate triangles here. So we have the 30-degree angle, that's 200 feet, and that's to the top, or this is to the deck. Okay? Then we have a little bit taller one, so he's looking 40 degrees up now. It's still 200 feet, but this is to the top of the observation deck. So what they want to know is they want to know the distance here, the difference. Let me get something a little bit darker. They want to know this distance right here. So how am I going to find that distance? Well, I'm going to take the distance from the top of the deck, and I'm going to subtract the distance to the observation deck itself. So I'm going to subtract those two distances. So I'm going to have to do this twice and basically calculate the problem with subtraction. So I'm going to start with the 30 degrees. So I have opposite. So I have an opposite here. And I have an adjacent, so again, we're going to be using tangent. So I have the tangent of 30 equals x over 200. Cross multiply, then I have 200 times the tangent of 30. So the first one's going to be 115.5 feet. So to the actual deck itself is 115.5 feet. All right, so now we're going to do the same thing, but we're going to do it to the top of the actual deck. So again, from 40, we have an opposite. And I'm going to actually call this one y this time, just so we know that there's a difference. And we have an adjacent. Okay, so I have the tangent of 40 is going to be y over 200. So cross multiply, and we get 200 tangent of 40. So I have 200 tangent of 40, and y equals 167.82. All right, so to find that difference, we're going to subtract it. So I have 167. We'll just do 167.8, and we're going to subtract 115.5 and 167.8. Whoops. Minus 115.5, and we get the 52.3. That's that distance between the deck itself and the top. Now, I do have some more problems that I want to go over with you guys. However, I'm going to wait and give you a chance to kind of go through these and get an opportunity to practice some of the basics before I throw some more multi-triangle ones at you that actually require a little bit more systems. So we will pick back up with this tomorrow, and let me know if you have any questions on these current ones.